For our do now, I brought back some of our construction, so we haven't done in a while. Number one, we are constructing the angle bisector. So, do any of you remember what our first step is here when we do this? Anybody else remember? You guys remember what we do first?
Arch with your little thing.
Yeah, we're going to start by making an arc. And what's my starting point? Where does my pointy end of my compass go?
To the little where the two lines connect.
Yes, right here. What is this point called?
I'm not doing it wrong the whole time.
Uh-oh, what were you doing?
I was putting the point at the both of the lines.
Ah, that would be the next step. So here, let's start with this first. First, we always start with the vertex. So maybe we could make a little note. That's step one. And the difference between making the angle bisector and a line segment perpendicular bisector is we actually want to use a smaller opening whenever we make this. So I'm going to put the pointy end of my compass right on the vertex, and I want my compass to be open less than half the side length. If I open it too big, my bisector is going to be way off the page. So we actually want to work in a smaller area here. So I'm going to put my opening here, put my point on the vertex, and I'm going to make an arc that crosses both of the lines like that. Okay. Everybody got that so far?
Yeah.
Awesome. So now for step two, does anybody know where we're going to go next? Where does our point of our compass go next?
So lines and lines.
Yeah, we're going to go to either one of these intersections we just created. So step two could be either one. We're going to keep our compass opened at the same width that we did for that first arc. So to measure and make sure, we just go from point to point, make sure it's open at the same width. Now I want my arc that I'm making in step two to go in the middle of my angle. So maybe about here. And I'll do the same thing on the other point I made. Here, and I'm making another little arc. And I bet you can already guess where step three is going to go.
Where those two lines.
Yes, we made another intersection right in the middle of our angle. And do you guys remember what the word bisector means? Anybody remember? Or can we make a guess what it means? So remember, whenever we did a bisector of a line, we split the line in half. So what do you think we're doing with this angle?
Split it in half.
We're splitting it in half, exactly. Bisect means split in two equal parts. So we now have this third intersection here, and this is going to be step three. And all I need to do is take a straight edge and connect the dots from my vertex past and through this new intersection I created. Just like that. Now to complete this angle bisector, just like with a perpendicular bisector, there's certain things we need to label to show that we did it correctly. How could I show that these two angles have the same measure now? What could I do?
The line here
Say it again.
is one line and two lines, right?
One line and two lines. What do you mean one line and two lines? Like on your rays or
In the middle where the vertex is.
right here?
Honestly, I think it's one line and one line. This regular place is the exact same.
So to show that lines are the same length, remember we do little dashes.
If you do.
But how do we show that angles are the same length
You do.
or same degrees? Yes, an arc.
That's
We're gonna draw arcs. Is that what you meant?
Yeah.
I gotcha. Yes, so we want to draw little arcs in here. And this tells us that these angles have the same measure of degrees. Perfect. All right, you guys all got number one copied down.
Yep.
Any questions about number one? All right, let's move on to number two. I bet you guys are froze at this now. So for number two, what is my first step? What should I start with? Where should my point go? What do we think?
Halfway move it,
My point here, you think?
or both.
On the ends, yes. We want to put the point of our compass on one of the end points. Doesn't matter which one we start with. And then how far should my compass be opened? Yeah, at least halfway. You could go all the way to the other end point, but remember, the bigger we have our compass open, the further away those intersections are going to be. So it might go off our paper. So we don't want to make it too big unless we know it'll fit. As long as it's more than half, it'll work. So I'm going to start like this. I'm going to turn my paper so it's a little easier for me. And I need to make our about like that. Okay, so I've done that. That was my first step here. What would be my second step now? Where should I put the point of my compass next?
On the other dot.
Yeah, on the other dot. What's that dot called? Bless you. What do we call dots on the ends of line segments?
End point?
Yes, an end point. So we want to put the point of our compass on the other end point. And how wide should my compass be opened this time?
The exact same.
Yes, the exact same as your first arc you made. You want it to be consistent, or else your line that you make that goes through it won't be a perpendicular bisector. So now we just need to create another arc so that we have two intersections, one above our line and one below our line. So I'm going to mark that here with step two, and these could be reversed. It doesn't matter which endpoint you do first, as long as you do them both. Okay. Now, what do I do in step three?
Draw one. New points you think.
Yes, we made two new intersections here. I'll mark those. And we just want to draw a line that goes through these two intersections that we created. So let's do that. I put my ruler or my straight edge up against those lines or those intersections. We're just going to draw a nice line going through. And sometimes it's hard to tell when it's tilted, but if we turn our paper so that the original line is going straight across left to right, we can tell that looks pretty accurate. That looks pretty good to me. So are we done with our perpendicular bisector now?
No.
No. What do I need to do still?
You need to draw both.
Mhm.
Two lines. Tell you both sides are. Backwards to it.
Congruent. Yes, or they're the same length. So we need to draw our little box to tell us that we made a 90-degree intersection. And we need to mark that these two lines line segments are now the same length. They're congruent. Perfect. Okay, everybody got that? Any questions about number two? You feel okay about it? All right. You still working on that one?
Yeah.
What's got you messed up on number 2?
Drawing the two bisectors.
Just drawing the bisector. Is it the arcs that are messing you up?
Yeah, I keep getting them facing opposite of each other.
Oh, okay. So tell me, how are you positioning your compass? You've got your point touching. Do you start with an endpoint? Okay. And then how far open are you making it?
Trying to eye it halfway.
Right at half?
Yeah.
Okay. So are you just not getting your half circles to touch each other? Are they a little bit further apart?
They're a little bit further apart.
Okay, so here's what's happening. I'm going to draw an example of what I think you're doing. And this might be helpful for everybody. So when we have a line and we're trying to draw that perpendicular bisector, if our compass isn't open big enough, here's what's going to happen. Okay, well, that shouldn't happen, but whatever. So see how these aren't touching? Is that kind of what you're coming up with?
Yeah, but it's further apart.
Just a little further apart. So whenever we make the perpendicular bisector, your compass needs to be open far enough or wide enough so that whenever I draw my arcs, I'm going to get an intersection and they're going to cross over each other. If they're too small, they won't ever reach. So I think the issue you're running into is your compass just needs to be opened a little bit wider. And that should fix it for you.
That's why I try to go over halfway.
Yes,
Try to get
that's
that.
good. It's easy to mix them up because with our angle bisector, we do want a really small opening. But with the perpendicular bisector, we want it to be a little bit bigger.
Yeah.
Did that work? Is it crossing now?
Yeah.
Good, 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 good. Okay, awesome. All right, let's look at number 3 now. We did a lot of stuff like this yesterday where we were solving for x using some angles. So first of all, on number 3, can somebody tell me what's happening here? Well, I know you weren't here yesterday, but it's okay. You get a little pass. What's going on here? How am I gonna think about this?
The corresponding,
Ooh, very close.
like you label each corner and then they will look on top of each other. They're across and that you have one set equal to the other set.
Yes, you do have some angles that are going to be equal to each other. I'm going to pull up the notes we took yesterday about these types of angles and see what we recognize. So remember, whenever we have angles that are across from each other, let's find where E and G are in our lists. I see C and G for corresponding. I see E and A for corresponding. So it's not a corresponding angle.
Oh, it's vertical.
Yes, it's a vertical angle. So whenever we have angles that are across from each other, these are called vertical angles. And vertical angles are congruent, or they have the same measure. So I know that these two angles here, since they're right across from each other, they are the same measure. So I know they're equal to each other. So for example, let's say this was just called A and this was called B. I could write an equation that says A equals B. But I'm not trying to find A or B. I'm trying to find X. So what could I replace A and B with to start the process of solving for X?
4x plus 7 equals 2x plus 3.
Yes, that is perfect, Ella. So all I'm going to do is take these values they gave me and write the same kind of format here to set up my equation. I've got 4x plus 7, and that's equal to 2x plus 3. Okay, so now we have a problem. We need to solve for x, but we've got a complicated equation where we've got x's on both sides.
First, move one of the x's to the other side. I didn't say 2x, move them to the or it's
You're awesome, Ella.
because that would have helped them to negative one, but it makes it negative.
Yes. So what we need to do first, just like we talked a little bit about this yesterday, whenever we're setting up an equation and we have more than one x or more than one number without a variable like our 7 and our 3, we want to start by trying to combine our like terms. So we have 4x and we have 2x, and they are on opposite sides of the equal sign here. So in order to combine those, we're going to have to do the opposite here and move it to the other side. So just like Ella said, to prevent getting a negative x, I don't want to subtract 4x over here. Let's start by subtracting 2x from both sides. You could subtract 4x, but this might give us a slightly more clean answer. Okay, so what happens when I do 2x minus 2x on this side?
Cancels out.
Yeah, they cancel out. So I'm going to cross those off. And what happens on the other side of my equation when I do 4x minus 2x?
It turns 2x.
Yeah, if I have 4 x's and I take 2 of those x's away, I've got 2 x's left. And what do I do next? Yeah, let's bring down the rest of our equation. I've got plus 7. I've got an equal sign. And I've got a 3. Okay, so now I have 2x plus 7 equals 3. What should I do now?
7.
Yeah, let's subtract the 7 to get x closer to being by itself. So minus 7 on this side and on the other side. And what happens to my 7s?
They cancel out.
Good, they cancel out. What's 3 minus 7?
Negative 4.
Negative 4. We are going to get a negative number here. So 3 minus 7 is negative 4. And what's going on the other side of my equation? What should I do now?
Putting down the 2x.
Yeah, we want to bring that 2x down. Almost done. Now I've got 2 times x equals negative 4. How am I going to get rid of this times 2 here?
Divide the 2.
Yes, I'm going to divide by 2. And that's going to get x by itself. I got to do that to both sides. So since my 2's cancel out, 2 divided by 2 is 1, so I've got 1x. We don't need to write the 1, bless you. We just know there's 1x left. X equals, what's negative 4 divided by 2?
Negative 2.
Negative 2. Job. And that would be our answer, guys. X equals negative 2.
It's all in my nose because I heard crises.
I'm sorry. Those allergies, girl.
Yeah, they're not pleasant.
Okay, now guys, I want to really encourage you. If you are feeling confused, please tell me so we can talk about it. I promise I won't be annoyed with you. This is a tricky problem. Is anybody feeling lost with it? Good. Yay! That's wonderful news. Okay, awesome. Awesome, awesome, awesome. All right.
Kind of lost on your name.
Okay, which exit ticket is that? Day 5?
Yeah.
Okay, day 5. Let's look at it. Here's our day 5 exit ticket. All right, so you guys remember doing this one? Yeah. So let's first figure out what we know about this little set of angles here. I'm gonna have you tell me, Selena, what's something that you notice in this little given set of angles here? They all have that same angle. How many degrees is that angle gonna be? 90 degrees. Good. We know that because there's this box here that tells us that it's 90 degrees. So that means these angles also add up to 90 degrees. So let's say this wasn't 4x plus 1. Let's say this was A. And let's say this wasn't x plus 14. Let's say it was B. What could I say about A, B, and 90 degrees?
A plus B equals 90 degrees.
Yeah, we know that because A and B are angles that are just inside of that 90 degrees, we could say A plus B equals 90. So all we need to do there is replace our A with 4x plus 1, replace B with x plus 14, and then we'll combine our like terms and solve it like a normal equation. Does that make sense?
Yeah,
Okay, good. Awesome. And we can,
that's what I did, but I got 4x equals x plus 13. I don't know what to do after
okay,
that.
4x equals x plus 13. Let's see. Can you tell me what you wrote for your original equation?
I did 4x plus 1 equals x plus 14. And then I took the 1 out.
Ooh, but let me stop you real quick. Are these angles equal to each other? No, they're not equal to each other. So we're not doing the same thing as we did in the do now, where's my do now? These angles are equal to each other. So we knew A equals B, and we just plugged in 4x plus 7 for A, 2x plus 3 for B. Instead of A equals B, this time we have A plus B equals 90. So we wouldn't set it up like this. We would need to set it up in a slightly different way. So here's our A. Here's our B. Okay. Do you see where we would put it in to set that up? Or do we want to run through it a little?
Yeah, I get it.
You get it now? Okay, good. So I want you to tell me, just to make sure you are on that right track, what's your original equation going to look like now?
4x plus 1,
Mm-hmm.
add that here, x plus 14.
So you said add those together? Yep, that's right. And what are you going to set it equal to?
9.
Exactly. You got it, girl. You got it. All right. We got a little bit of time. We might not end up doing the quiz on Thursday, and that's okay. I wanted to do it Thursday, but I also don't ever want to give you guys a quiz if I don't feel like we're ready for it yet. And I think we needed a little review today, and that's okay. That's totally fine. Let's go ahead and move on though to what we were going to talk about today. So I would love for you to get out your notes and start a brand new page. We're starting something totally new today. Still Unit 1 though.
It'll be Unit 1 till we have quiz.
Yes. We'll be in Unit 1 until we take the quiz. So I'm going to title this Geometry Unit 1. This is page 2 of our notes today. Day 6 continued. And let me grab my little cheat sheet. What we're doing today. I am going to give you all a piece of paper that has some. I know. I can just tell you're so excited. You are welcome. Now we're going to talk today about something different. First of all, how familiar give me like a scale of 1 to 10, how familiar do each of you feel with plotting points on a graph? Like if I told you to plot the point 2, 3, would you be able to do it with confidence? Okay, yes. How about you, Ella?
About 6.
Okay, okay, about a 6. And are you about in the same range, Selena? Okay, all right, that's all right. Let's have a little review. I'll wait for you to get settled. So whenever we are looking at points on a graph, first of all, we need to know that there is an x-axis. That's the one that goes left to right. I'm going to mark it in red. And then there's a y-axis. The y-axis goes up and down. That in blue. And I had that labeled on your paper as well. So you guys should be able to see that already. So whenever we are looking at x values, going left to right, our 0, it's like a number line. The 0 is going to be right here in the middle. And to the right, we have all of our positive numbers. So 1, 2, 3, 4, 5. Okay. And whenever we cross 0 and go to the left, what kind of numbers are we going to have there? Negative numbers. -1, -2, -3, -4, -5. Now let's look at our y-axis. Our y-axis also starts with 0 right in the middle, and it goes either up or down. When we go up, we're going to have positive numbers. So same as how we labeled our x-axis, I'm going to count on each little tick mark. 1, 2, 3, 4, 5. And if my up direction for y is positive numbers, what kind of numbers do you think we'll have going down? Negative numbers, exactly. -1, -2, -3, -4, -5. Okay. So let's look at this point I gave you. I gave you the point or a coordinate. Coordinate is 2, 3. So whenever you're looking at a set of 2 numbers with a comma in between them in parentheses, this is just giving you a location on a graph. The first number in your coordinate is your x value every time, and that will never change. The second number in your coordinate is your y value. And again, that will never change. So whenever we are plotting a point on a graph, we're going to use this like a map. This map is telling me to go over 2 in the x direction and to go up 3 in the y direction. So I'm just going to go from 0, go over 1, 2, and then I'm going to go up 1, 2, 3. And there's my point. 2, 3. So go ahead and mark that point on your graph and label it. Zoom that in a little better for you guys. Okay. Let's plot another point. how about we try -3, -4? So in this new point, -3, -4, which number is my x value?
-3.
-3, perfect. So going left to right, I'll start at 0, and I'm going to go over -1, -2, -3 in the x direction. And how many up or down will I go from here?
Down 4.
Down 4, perfect. 1, 2, 3, 4. So here's my second point. -3, -4, so we'll label that too. All right. So what I would like you to do with these 2 points we just plotted is I would like you to take a straight edge or a ruler and connect these dots so that we create a line segment. Don't go past the endpoints. I want you to just make a line segment. Perfect. So your page should look just like mine now. Zoom out a little.
It's not centralized line, but it
That's okay. It doesn't have to be perfect. So let's say we wanted to figure out where the middle of this line was. We could construct a perpendicular bisector, absolutely. But let's say we don't have a compass. All we have is these points and a graph and a calculator. I'm going to show you a new thing today. Here's what we're going to put in our notes. I would like for you to write in your notes, finding the midpoint on a graph. So I'm going to have you copy down a formula that we're going to use. This is called the midpoint formula, right? Midpoint formula. Now, I personally am going to recommend using colors in your notes because I think sometimes, at least for me, when I'm looking back at notes and everything is all black and white, I have a hard time remembering what each piece is. And I like to color code whenever we're crafting. I always make my X's red. I always make my Y's blue. That's just how I do it. You don't have to do that, but I am going to recommend it. It might be helpful to you.
No, has to write in color.
I have all kinds of colors for you on the table. So those little rectangle bins should have lots of different colored pens. You're welcome to use them. There's highlighters. There's all sorts of things. Actually, let me give you guys something. I'm gonna pause this video. I have a gift.
Like this.
All right. So here is that midpoint formula. I'm gonna start by writing a big parenthesis like this. And then I'm going to use red because I'm doing X's. All right, X1, put a little 1, and I want to leave space here. I'm making a little, going to be a fraction. X1 plus X2 divided by 2. Okay? And then a comma. And then we're going to do the same thing with Y's. y1 plus y2. All of that is divided by 2. Then we'll close our parentheses. So whenever you're looking at this as a whole, it looks like a scary formula, but when we break it down, it's really, really not. All we're doing is finding the average x and the average y, and this answer is going to be a coordinate. You see how we have a value, a comma, and another value? Your midpoint should come out to be an x and a y. That we can put on a graph. So let's go ahead and try to use this formula and find the midpoint of this line segment that I gave you. So the first thing we need to do is decide which value is going to be x1 and x2, which one's going to be y1 and y2. It really doesn't matter which one you choose. It really doesn't, but I'm just going to label it for fun. Since I did 2, 3 first, I'll make that x1, and I'll make my -3 x2. And then I'll make whatever I made x1, I need to make its pair or its partner the y1. And whatever's x2, its partner needs to be y2. Everybody with me so far? So I'm just labeling my x's and my y's in those original coordinates I gave you. Okay? So now let's use these in this formula. So I'm gonna draw my big parentheses. And what's my value for x1?
2.
2, perfect. So I'm gonna write 2. And then what's my x2?
3. -3.
-3. So I'm gonna say minus, well, it was plus actually, plus -3. And we're gonna divide that by 2. Okay, then we're gonna look at our y's. What's my y1?
3.
3, perfect. And what's my y2? -4, good. So now we just need to solve each of these problems. If I do 2 plus -3, type that in our calculator if we want, or we can know that if I've got 2 and I take 3 away, how many am I going to have left? 1, almost. -1, good. So now I have -1 over 2. And here, I'll keep my colors consistent. -1 over 2. And how about 3 plus -4? Or 3 minus 4? That's going to get me pretty similar to the first one. So if I have $3 in my bank account and then I spend $4, how much am I going to have in my bank account? -1. Good. So same number here. -1 divided by 2. Okay. So my new coordinate, you could leave them as fractions if you want, or you could write them as decimals. I will have -0.5, -0.5, Or you could just leave it as -1/2, -1/2. Both the answers are correct. And there's my x and there's my y. So I'll circle both of these. Either is correct. Okay. So we've used that formula. Now we want to plot this point that we just came up with. So what's my x value of my midpoint?
-1.
Almost. We had -1, but then we divided it by 2.
0.4.
Yeah, -0.5 or -1/2. So I'm going to start at 0 on my x-axis. And I'm going to go over to the right or the left. The right is my positive numbers. The left is my negative. If my x value is negative, which way should I go?
Left.
To the left. Good. So it says I'm just going to go over to the left about 0.5, so about halfway. And then what's my y value?
0.5.
Yeah, -0.5. So will I go up or down on the y-axis? Down for negatives. And I'm going to go down about 1/2 of the way. And there's my midpoint. And we'll label it -0.5, -5. Like that. Okay, guys. I'm thinking we just introduced that today. We're going to do a bunch more practice with this tomorrow. Let's give you a break today. I'm not going to give you an exit ticket for today. I think that when we come back tomorrow, a really good use of our time would be to spend a lot of time practicing this, making sure we feel good about everything else. And I think, why don't we plan on trying to do that quiz, not Monday. I don't like Monday quizzes. Let's shoot for next Tuesday-ish. Next
Because we've gone
Tuesday.
a weekend without.
Yes. I like to give us a day of review before that. So we're going to try and do our quiz on next Tuesday. Today, no exit ticket. Just wanted to introduce that to you. If it's not quite clicking yet, that's okay. We're going to do a bunch of practice with it tomorrow. I just wanted to introduce it. But you guys are free to go. That is all. Unless you have questions, then you're welcome to stay in that recording there.